Effective people focus their time and energy on the things that can create miracles in their learning process. I am forever grateful to all my effective viewers for joining me for this video today. You might have heard that one habit of ultra successful people is that they learn a lot. And I hope that you learn something which is very, very important today. The topic today is exact differential equation. And this topic is from differential equations of first order and first degree. So here we are going to discuss few problems. And first of all, I'm going to teach you what is an exact differential equation. See here, when an equation which is of the form m dx plus n dy is equal to 0. See how we have to identify that it is an exact differential equation. So here is a small test that, so we have to select m and n. So we have to make a derivative. So dou m by dou y. So m with respect to y and n with respect to x. Clear? If the both values are same, if dou m by dou y is equal to dou n by dou x, then we say that the given equation is an exact differential equation. Then what about the solution for this? The solution has a formula that, see here is the solution. So how to find the solution for the differential equation? See, this will be integral m dx. So we have to pick m from here. So we have to pick m from here. This is m dx plus the terms independent of x in n into dy is equal to 0, or else, see here, there is a terms not containing x. Terms, we have to choose the terms not containing x in n of dy is equal to 0. So this is the solution here. So here we have to, first of all, the equation is like this. M dx plus n dy is equal to 0. So we have to pick m and we have to pick n. So m we have to make a derivative with respect to y. N we have to make a derivative with respect to x. If both values are same, then we say that the given differential equation is an exact differential equation. And how to find the solution? Solution is nothing but m dx plus the term independent of x in n of dy, or else the terms not containing x in n. So we have to neglect the terms which are containing x in n of dy is equal to 0. So I'll show you a few examples and which are very important. See here, the first question here is e power y plus 1 cos x into dx. So this is of the form, see here, the question is of the form m dx plus this one is n dy, which is equal to 0. So what is our m value? So m is nothing but, see here, which is very clear, m is nothing but e power y plus 1 into cos x. And what is our n value? So n is nothing but, so on comparing e power y into sin x. So we have to make a derivative m with respect to y. So here dou m by dou y value. So here there is y. E power y is e power y, and for 1 this is 0 into this value is cos x. So this will be, so dou m by dou y value is equal to e power y into the value here is cos x. And for n we have to make a derivative with respect to x. So as it is a multiplication, I am leaving it as a constant part, as I have to make a derivative for sin x, the value here is cos x. So here we got dou n by dou x value is e power y into cos x, and this is also e power y into cos x. So here both the values are same. So this is same and this is same, and therefore we conclude that dou m by dou y is equal to dou n by dou x, and we say that the given differential equation is an exact differential equation. Clear? So now we have to find the solution. So how to find the solution? There is a formula here, that is m dx plus the terms not containing, see here, the terms not containing x in n of dy is equal to 0 or is equal to c. See here, if you observe here, what is m here? So m I have to pick from the question. So this value is m. So m is nothing but e power y plus 1 into the value here is cos x into dx plus the terms not containing x. So here there is terms containing x are there. the terms not containing x. So here there is an x here and therefore we are leaving this one. So there are no terms which are not containing x. So 0 into dy which is equal to 0. So if I integrate this with respect to x, so this will be the constant, that is e power plus 1. For cos x, the value here is sin x. Clear? And this is already 0 which is equal to c. So here the final answer is e power y plus 1 into sin x is equal to c. This is the this is a solution for the exact differential equation. This is how we have to find out. First of all, we have to select m and n. We have to make a derivative with respect to y for m, and we have to make a derivative with respect to x for n. And if the both are equal, we say that it is an exact differential equation. And this is the formula, the terms not containing. So here there is a term containing x, and therefore there are no terms which are not containing x, therefore I kept 0 here, and this is the final answer. And our second question here is also so easy. Same steps here we have to write, as this is the second question. So again this is of the form m dx. So this is of the form m dx plus n dy is equal to 0. So if you choose m, so what will be the m? So here this will be y square minus 2xy is m. And what is n here? This is minus x square plus 2xy. And now we have to make a derivative. So with respect to y here for m. So this will be 2y. For y it is 1, this is 2x. So for dou n by dou x. So here for x square this is minus 2x. For x it is 1, this value is 2y. So here if you observe, this value is dou m by dou y is equal to this value is dou n by dou x, and therefore we say that the equation is exact. So we say that if both the values are equal, we say that it's an exact differential equation. So if it is an exact differential equation, what we have to do? So we have to find out the solution, that is m dx plus the terms not containing x in n of dy is equal to 0. So here what is this m here? So m is nothing but y square minus 2xy. So this value is y square minus 2xy into dx plus the terms not containing x. See here, there is a term containing x here, leave it. There is a term containing x here, leave it. And there are no terms which are not containing x. And therefore this is 0 dy is equal to c, and therefore y square, if you make a derivative with respect to integration with respect to x, so y square will be constant and this will be integral dx minus 2y is constant integral x into dx, which is equal to 0. So here this is y square. So integral 1 into dx is nothing but x minus 2y. For x it is x square by 2, which is equal to c. If I cancel this one, the value here is y square x minus x square y is equal to c. And this is how we got the solution for the exact differential equation. So here each and every step is clearly explained. And our third question here is, see here one after the other, if you check this one. So here if you see, so this is of the form m dx plus this value is n dy. Clear? So what is our m value? M value is nothing but 1 plus e power x by y. And what is our n value? That is e power x by y into 1 minus this is x by y. So I have to make a derivative with respect to y for m, that is dou m by dou y value is equal to, for 1 it is 0. For e power x, this is e power x. For there is y here, x will be constant, and for 1 by y this is minus 1 by y square. Clear? And therefore if I make a derivative for n with respect to x, so this value is u and this value is v. First dou n by dou x, if I make a derivative with respect to x, e power xy value is e power x by y, and with respect to x this is 1, and therefore 1 by y is left over, and this is, we have to keep v as it is. And next time I have to leave u as it is and I have to make a derivative for this. one value is 0, and for x this value is 1 and this value is 1 by y. So here if I multiply this one, so if I multiply, this will be e power xy into y, and if I multiply further, that is x into e power xy by, the denominator will be y square, and this is minus e power xy by y. So if you observe, I can cancel these two, and dou n by dou x final value is minus x into e power x by y square. And here if you observe, dou m by dou y value is equal to, if I multiply all these, this will be minus x into, so this is x into e power xy by, this value is y square. As you can see that both the values are same, and therefore I conclude that dou m by dou y value is equal to dou n by dou x, and therefore I say that it is an exact differential equation, as both the values dou m by dou y and dou n by dou x values are equal, and therefore we have to find the solution here. For finding the solution here, this is m dx plus the terms not containing, see here, the terms not containing x in n of dy is equal to 0. See here, so what is m here? So m value is very clear as 1 plus e power x by y. This is 1 plus e power x by y integral dx plus the terms not containing x. So here there is an x part, leave it, and here if I multiply there will be x, and if I multiply there will be x, and therefore there are no terms containing x. So this value is x in y. So therefore 0 into dy is equal to c. And therefore if you observe this one, so this is going to become, so I have to make an integration, that is 1 into dx plus this is e power x by y into dx, which is equal to, the value here is 0. So this is 0. So 1, the value here is x, and for e power x by y, this is e power x by y. For x it is 1, therefore this is 1 by y, which is equal to c. So if I make an LCM, this will be e power x by y is equal to c, and therefore this value is xy plus e power x by y is equal to yc, and therefore this is the solution for an exact differential equation. See here, this is also so simple, and the next question here is, the fourth question here is x into e power x into y plus 2y dy plus dy by dx plus y into this one. So first I am going to transform this equation. See how I am going to transform this equation. I am taking dx as LCM. So this will be x into xy plus 2y into dy plus y into e power xy into dx. After taking dx as LCM, and I am multiplying with 0, and this will be 0. So first of all I need this equation in the form m dx plus n dy. So y into e power xy dx plus this value is x into e power xy plus 2y into dy is equal to 0. And therefore this is of the form m dx plus this value is n dy is equal to 0. And what is our m value? So m value is nothing but, see here, m value is nothing but y into e power xy. So what is our n value? X into e power xy plus 2y. So first I have to make a derivative with respect to y for m. So dou m by dou y value is equal to, there is y here and there is y here. So this y I am making 1, and I am leaving e power xy. And next time I am leaving this y, and for e power xy this is e power xy, and again for y this is 1. What is left over? X is left over. Clear? And for n, so we have to make a derivative with respect to x. So here there is x, keep it 1, and e power xy. Now we have to leave x here, and for e power xy this is e power xy. For x it is 1. What is left over? Y. And if you write it properly, dou m by dou y is equal to, this is e power xy plus xy into e power xy. And see here, this is dou n by dou x. This value is e power xy plus xy into e power xy. So if you observe this one, so both the values are same. and therefore we can conclude that dou m by dou y value is equal to dou n by dou x, and therefore we say that it's an exact differential equation. So it is an exact differential equation. So here for this, what will be the solution here? So here the solution part is integral m dx. So integral m dx plus the terms not containing, so here the terms not containing x in n of dy is equal to 0. So here, so this is going to become integral. What is m here? So m is nothing but y into e power xy into dx plus the terms not containing x. So there is an x here, leave it, and there is no x here. Therefore, this is the term which is not containing x. So what is there here? 2y into dy is equal to 0. So if I make an integration with respect to x, y acts as a constant. So this will be e power xy dx plus 2 is a constant. This is y dy is equal to 0. So for y, e power xy value is e power xy. For x it is 1. What is left over? Y. And this is 2. For y, this value is y square by 2, which is equal to c. So if I cancel all these, so here this will be e power xy plus y square value is equal to c. And this is the general solution for the given exact differential equation. So this is how we have to solve. First of all, we have to take m and n from the given equation. So we have to write it properly here. We have to take m value and n value, and m is should be differentiated with respect to y, and n should be differentiated with respect to x. And after that, we have to check dou m by dou y equal to dou n by dou x. If both are equal, we say that it's an exact differential equation, and this is the equation. So this is the formula for the solution here, that is m dx plus the terms not containing x in n of dy is equal to 0. So we have to pick the terms which are not containing x. So there is a single term here, that is 2y, and after making an integration, the final answer is like this. So if you really understand, see, please practice for one time or two times, or silently for 3 or 4 times, but definitely you have to perform in the examination, and you will be getting a good score if you practice well. And if you really like, please raise your thumb, pass it on to your friends, and subscribe to this channel, and stay connected for more solutions. And thank you so much for watching and staying till the end.